Hi, this is our final CPEN 291 project. We created a web application called OMO that helps you find your favorite songs, animes, and podcasts. My name is Caleb.
And my name is Max.
I'm Ryan.
I'm Susan.
And this video will help be a brief summary of the technologies used in our project to create the final application, as well as a walkthrough the web application under operation. A full description of the project can be found in our final report listed in our repository on GitHub. We'll first discuss the problems as well as the solution to the problem that we're currently trying to solve. We'll also discuss the sentiment analysis model and the recommender systems used in our application, as well as a demo under operation. Under the current circumstances of the COVID-19 pandemic, people around the world are feeling more lonely. 4 out of 10 Americans 4 out of 10 Canadians, according to the Surrey Now paper, shows that Canadians are feeling lonely or socially isolated during the pandemic. The rate of depression and anxiety has been higher than ever before. From research, we discovered that writing journals allows humans to have a stronger connection with ourselves, and it lets us move past negative emotions. For these reasons, our team has decided to develop an application that lets us both dump our feelings while also assists the users by lifting their mood by recommending music, anime, and podcasts based on their entries. our our team developed a natural language processing model for sentiment analysis. We first used the emotions in text dataset to train this model. The dataset consisted of over 21,000 entries in the format shown below in the image. This format contains a text sentence where the user describes how they're feeling, as well as a emotion label attached to it. The reason we chose this data set is because it contains the sentiments we wanted, including sadness, anger, fear, love, surprise, and happy. Our sentiment analysis model uses NLP techniques and included cross entropy to calculate its loss. The layers included a word embedding layer, LSTM layer, and a linear layer, as well as after training and tuning hyperparameters, we managed to achieve 91% using the emotions dataset.
So we made 3 separate recommender systems for 3 different types of media, these being music, anime, and podcasts, providing more flexibility and choices for our users. We felt that 3 was enough for the user because the 3 of music, podcasts, and anime sort of cover most of what people would like to do in their free time when maybe they're feeling sad or when they're feeling happy. So as for the music recommender system, we found a very good data set on the internet curated by a user on Kaggle, which uses the Spotify API, which is a music streaming service, to gather tracks into a data set, which contained about 600,000 songs. So because there was that many songs, we decided to cut down on the number of songs to around 2,200 or 22,000 because there was a metric on the data set called popularity, and we felt that the less popular songs might not be useful to recommend to people. This data set also contained other various metrics that were quantitatively defined by the Spotify API, such as danceability or valence or acousticness. And some of these metrics were not actually useful to our analysis, such as loudness, tempo, or time signature. So we cut those out of our data set. So using this data set, we developed an algorithm for our model to give scores to each of the track. These scores are based on these metrics that are defined by the data set for each track. as well as based on the input sentiment that the user gives. And our algorithm chooses 5 of the top few tracks that that have the highest score, and these tracks are chosen to be recommended to the user.
For our podcast recommender system, we found icons datasets with over 13,000 podcasts on Kaggle. The dataset contains columns describing about the podcast and the genre it belongs to. Looking at the datasets, we realized that podcasts were classified under over 60 genres. So we figured cutting down this genre for podcasts would give us better accuracy for multi-level classification. For this, we picked out genres which had more number of podcasts and was more relevant to our target. We then decided to apply the LSTM model to our datasets to predict the genre. Our algorithm predicts one of the 5 most relevant genre with 82% accuracy, and the podcast from that particular genre is then recommended to the users. For our anime recommender system, we got the datasets, anime, movies, and OVAs and TV shows datasets from the Kaggle. It consists of over 16,000 animes and TV shows with columns with its synopsis and the genre it belongs to. So the model uses similar algorithm to that of the podcast datasets. And we use this LSTM model to predict one of the 5 most relevant genre of anime with 78% accuracy, and that animes from that particular genre is being recommended to the users.
As a quick preface to the demo, the entire project was built in Django, as it is a relatively lightweight framework, and it allows for quick development and streamlines the entire design process. The front end was done in HTML and Jinja, which is a templating engine, and allowed us to make use of some of the built-in features that make it like very easy to display dynamic information in HTML. So when you first open the page, you're greeted by a prompt that asks for a brief description of your day. So something like, yeah, for example. The next page asks what kind of media you're interested in. You're also given the option to return to the original screen and enter a different input. The input from the original screen as well in this step is passed into a function which cleans it, removing all of the stop words and punctuation, and puts everything into lowercase so it can better be processed by the different models. Yeah, so once the models receive the input, they process it, and all of them return a list of all of the different kinds of media that we are deemed, I think, relevant based on the user input. If there are more than 5 elements in the list, the user is given the option to cycle through them. Furthermore, the user is given the option to browse other media based on their original input. So, like a podcast returns it, and they are also given another option to return, enter a new input, and then browse media based on that input as well. That concludes our presentation for CPEN 291. Thank you for your time.